Okay. For this video, we'll be talking about how to generate the design criteria. So let's review the process. First, we did the CDRC to review the documents that we received and advise the project lead what are the documents that still missing on the one from the one they provided to us. Then second, we generate the load mapping. Then third, we generate the concept framing, then continued it and did the concept sizing or the preliminary sizing. And after all those activities, we can now finalize our design criteria. Okay, so let's open again our file folder, the PSQ folder, SD1, then the design criteria. Rename it. Okay, and then open. So we already have a template for design criteria and others. Okay. So this is a template of our design criteria. Basically, we will just fill this up. Okay. So for the loads, reinforced concrete 24, soil 18, structure steel 77. These are general dead loads. And then for the superimposed loads, let's go to you need to open the load map of the load reference that you did. The Excel file will be better. Okay. So for the superimposed loads, we have although we didn't put the drop wall, but definitely we will have a drop wall along the way because we don't know the finishes yet of the exterior. So just put the precast wall there. So we have 2.8, 120, 100 mm. For the AAC, we didn't consider any AAC. So just delete this one. Don't need this one. For the CHB, we will be considering the certain part to be CHB. So, okay, so we can retain the AAC and the CHB so that we have an open option whether which wall we can use. So primarily we'll be using that one in this portion. If you remember I already closed. I'll open the architectural plan. Let's see the block 2 carbon and this one. The floor plans. Let's open the floor plans. So, but since this wall are beam load, so we didn't reflect it to the floor load or the load mapping, and also it will just be very small. So we will be using those walls here. If you remember, we put column here, and then we frame this one. Then we will be using walls here in this portion. Okay, those walls can be either precast, AAC, or CHB. It depends on the method and the architectural what they want. Okay, but on us, any of those items is okay. It's good. So to have an open option in terms of wall, we can retain these three materials. Then movable partitions. If you remember, let's go back to the Excel. We use 0.5. Okay. For toppings and finishes, we use 1.1. Okay. Ceiling, we use 0.5. Utilities, ceilings and utilities, we use 0.5. It's already combined. Yeah, ceilings and utilities, 0.5. Then we have floor fill. Floor fill, we use 1 point. How much? 1.15. And then do we have other load that we considered? Solar panel. So we consider solar panel. To be 0.5 kVA. So we can remove this one. Just delete it. Then for the live load, we have retail, storage, utility room, hallway, roof. So retail, sorry. That's why this will be easier if you already established if you follow the procedure. Retail, storage, because everything that you will put here was already done in the procedure, earlier procedure. Utility, hallway. Okay, so let's just delete this extra. So for the retail, we use 4.8. Then for storage, we use 12. For utility room, we use 12. Hallway, we use 4.8. Then roof, we use 0.6. So let's do this another storage area. Now let's go to the seismic load parameter. Okay, so we also established this one earlier. Okay, zone Z, ortons, tapos seismic zone factor 0.4. Okay, distance from the source 3.8. Then seismic source type C. Yeah, there, if you remember. Importance factor 1, standard occupancy, lateral force resisting system, special SMRF. Ductility factor, we use 8.5. Okay, so SD, near source, ito yun, NA, this one, NA, and then NV1. So, that's for the seismic. Then for the wind load parameter, we didn't establish the wind load parameter. So, we need to run through this one. Okay, but basically, this will be easier. For the basic wind speed, okay, let's go to the wind load. The mapping is not here, okay. So for the basic wind speed, so we just need to open the NSCP. Okay, we still have it here. And just go to the wind load. This will just be fast. Okay. So this is the wind load. So we are in standard occupancy, so category 2. So we can look at this one. This is Cebu. Cebu around here, somewhere here. So it's around 260, 250. So to make it conservative, we can use 260. Importance factor 1.0, standard occupancy. Surface roughness. So this is a city. So I mean, there were existing structures along in the perimeter of this structure. So the exposure category will be B, and then surface roughness will be B. Wind KD can always be 0.85. Topographic factors, since we don't have change in elevation, it's 1.0. Okay, so let's get it from the NSCP. So, okay, so this is the definition of the surface roughness. Here. So basically, for the category B, later we have the definition of that one. So this is the KD. So building main wind force 0.85. That's what we get. That's coming from there. This is the definition of the exposure categories. So since the building is surrounded by small structures, less than or equal to 9, that's why we define it as exposure B. Okay. Then, what's the next? Exposure B, topographic, the KZT. Let's look at definition. Just scroll down. Topographic effects. So here, the KZT can be 1.0. Okay, so that's from the code. Then gas effect factor. Okay, gas effect factor. Let's move around here. Sorry, because the code is too long. There's a lot of provisions right now in the code. There were also sample calculations, so you can also check. Okay, so this is the gas effect factor for rigid base structure or other structure. So we can make it 0.85. That's why it's already 0.85. Internal coefficient. Internal coefficient. Okay. So internal coefficient. Here. So internal coefficient factor. Open buildings. So we can use also the 0.00. Okay, because this can be considered as an open building. Okay, we can put 0.00. Terrain structure coefficient. So those things, Z. These items, we can just delete this one because it's quite complicated and something like that, right? It will be case to case in the per building. So those factors, you can get it from here, but it might take you longer, like this one, the KZ, roughness. So because that one you need to check for the factors. There's a lot of factor to be considered. So for the parameters, I think this will be enough for the preliminary parameters, design criteria, I mean. Okay. For the material specification of horizontal members, so we managed to define earlier that this can be 4,000 psi after our preliminary sizing. And then this will be 5,000 psi, the columns. Okay? Minimum yield of rebar, so for uniformity, we can use all as grade 60. For wire mesh, it's 276. Steel, we can use 250. By the way, we need to use 420. This is not 414. This should be 420 as per PNS. And then this is 250 as per PNS. Then electrode, this is genre of the electric or welding. This is for the welding classification. And then we have the bond, A307. Okay? Those mainly these are material specification, loading condition. Then the last part will be the methodology. For the foundation system, there is no geotechnical report available during the development of SD1. So we just assume soil bearing capacity of 75 kPa. If you remember, we assume 75 kPa from NSCP. Okay? Since the soil profile shows soil type of soil classification of SM. If you can remember earlier, we classified it as SM based on the Borlag data. Okay, so this one. So SM, it's silty sand. Okay. You need to mention that it's based on the nearby project. Borehole data. Which is Mandani. Okay? We don't have basement, so we just need to delete this one. So we can also, if you remember, we increase it. We increase the variable bearing capacity by 3 as prescribed in NACP 2015. Okay. We need to replace. We use large footings to increase the allowable bearing capacity by 3. So we can say, yeah. Okay. Then factor safety of 2 is used to define the safe bearing capacity. Okay. So safe bearing capacity equivalent to 100 kPa. 113 kPa. Okay. Based on retaining wall, so we don't have retaining wall, so we can just delete this one. We use, we can replace again because we need to discuss that we use isolated footing. So we use isolated footings. To increase the allowable. Large enough. We use isolated footings large enough to increase the allowable bearing capacity by 3. So maybe we should not put that. Foundation enough to increase the allowable. Okay. Isolated footings is utilized to support the columns of this structure. Okay, then we need to put the concept. Okay, we need to put the concept there. So where's the concept plan? Concept plan. Where's the concept plan? So we need to put this concept plan for them to further understand the strategy that we made. Okay, so just crop it and then put it there. So maybe we can make it better, bigger. Make it square so we can make it bigger. Okay, I think this will be enough. Anyway, we attach this will be enough. We attach the plan. Okay, then for superstructure, so lateral force resisting system, as I mentioned earlier, so we use SMRF concrete was utilized to resist lateral forces for this structure. Okay. Gravity forces will be taken care of by hollow core slabs and composite slab. Hollow core slabs. Okay. Hollow core slabs and concrete slabs. Hollow core pre-stressed and cast in place concrete slabs. Okay. Slabs will be supported by the frame girders, then which will be supported by column to ensure loads will go down to foundation. Okay, so simple, just a basic description will do, and description. So then just put the framing, concept framing. Okay, just put our ground floor. It's a ground floor concept, and paste it here. Change it as square, so you can enlarge them, enlarge it. Then okay, so we can discuss even this one. You can paste another picture of the round explore. That's why you need to finish already the load map, concept plan before doing the design criteria, finalizing the design criteria. Okay, so square, then increase it. Okay, like this, and then we need to have another page. Maybe we can have two. We can make it smaller, so we can paste two. Okay. Okay. So this is it. We're almost done for the initial part. So we can make it smaller, and then Make it go here. Make it a bit bigger. Maybe just put, let's make it big, and then you can just add another page. Okay. So the last part is the roofing or the roof structure. So roof beams are introduced as part of the SMR roof system. Also, this will support the truss system that will be modified to fit with the internal profile of the roof. As a sample, purlins will then be resting on the trusses to complete the roof system. You need to identify it's a steel truss system and then it's steel purlin, because there can be wood and any other material. You can launch this one, move it back, something like that, launch one, and then we're done. So this is design criteria. So just save it. Oh, we missed this one. Okay, it's standard occupancy. So we save it, we print it, save it at PDF. Okay, so I just put there design criteria 200709 block 2 design criteria. Okay, it's better to save it already in this folder, design criteria. So okay, so let's close this one. Let's finalize the documentation. Okay, so let's close this one. We don't need those things. We now go to the documentation, the final documentation. So you always have cover page. So make sure you have cover page for everything. So copy it, design criteria. So this is the cover page. Okay, so edit everything. I already have sample, so maybe just use that one because I already created a cover page for the earlier documents. So design criteria, cover page. Okay, so just change this one. Then document number. So you can always get it from our monitoring, output monitoring. So urban city, block 2, design. So everything is already here. You actually don't need to. You only need Veron if there's a case that when you look at here, you don't have the document number available. Okay, so just get it there, paste it here, change the format. Okay, then the signature. So make sure you still have space for the signatures. So you utilize the whole page, something like that. So prepared by the one who did it, verified by the manager should be me. But in this case, I prepare it so I don't have to sign the verified. Then co-verifier is the project lead, and then the approver should be Sir Bram and the project design manager. Okay? So I'll prepare my signature. So this is how I prepare my signature. I have a pre-C signed, then just edit it. Put the title of what I'm signing. City, DC, Block 2. Sorry, Block 2, DC. Okay. And just need to crop. Okay, so just put it here, paste it here. Change the wrap, make it square. Change the size, and that's it. Then you can save, print. Just put it like this, like criteria, cover page. Okay, then once it's done, you can do the final documentation. Go to the folder. These two documents should be combined. So we have this option, combined in PDFX viewer. Put the cover page on top. Okay. Okay, just put yes. Then this will be produced with a warning. So to make sure that there will be no warning in the document, just print it. Okay, print it and then put it in the proper folder. Design criteria. Okay. 200709 design criteria. Combine. Okay, so it's ready. Do not save this one. It's ready. Oh, sorry, I opened the wrong document. It's here. So it's ready. It's already combined. Okay, then after that, you need to, so we already finished the CDRC, concept plan, design criteria, load map. Then we just need to upload this on the Teams and then let Beron send in. Okay, so I think that's all for now. We have now the tutorial videos from CDRC up to design criteria. And I hope this will help and will make everyone faster, to finish faster. So everyone can just follow this one. Okay? Thank you. And I hope you can do more, do faster, and more accurate with this. Please utilize the procedure and the processes in the tutorial. It will help you do it faster. Less thinking. So if you are in doubt, just ask. Just ask to make it faster. Okay? You know you can do it. Everyone can do it. Okay? Thank you. And bye-bye.